According to the National Electrical Code Table 310.15 B16 for three-phase motors up to 1000 horsepower, the minimum ampacity of the conductors must be at least 125% of the motor full load current. In the case of this 250 horsepower air compressor, the full load current is 337 amps. Therefore, the minimum conductor ampacity is 125% times 337 amps, which equals 421.25 amps. Existing 500 MCM conductors are insufficient. Based on the minimum conductor ampacity of 421.25 amps, the required conductor size for a three-phase 480-volt system is 750 MCM copper with THHN insulation, or 1000 MCM copper if using other insulating materials. The existing 500 MCM conductors are rated for 337 amps, which is below the minimum required ampacity of 421.25 amps. Using conductors that are undersized can lead to overheating and potential safety hazards. When sizing conductors for motors, there are several factors to consider, including the motor's full load current, the ambient temperature, the type of insulation used in the conductors, and the distance the conductors will run. Firstly, determine the motor's full load current. This information can be found on the motor's nameplate. Secondly, calculate the minimum ampacity of the conductors. This is done by multiplying the motor's full load current by 125%, as per NEC 430.22. Thirdly, select the appropriate conductor size based on the minimum ampacity. This can be done using NEC Table 310.15, B16 or other relevant tables. Fourthly, consider the ambient temperature. If the ambient temperature is higher than 30 degrees Celsius, a temperature correction factor may need to be applied to the conductor ampacity. Fifthly, consider the type of insulation used in the conductors. Different types of insulation have different temperature ratings. Make sure to select conductors with an insulation rating that is appropriate for the application. Sixthly, consider the distance the conductors will run. If the conductors are run a long distance, voltage drop may become a concern. In this case, it may be necessary to increase the conductor size to compensate for voltage drop. The National Electrical Code provides guidelines for calculating voltage drop. It is important to consult the NEC and other relevant codes and standards to ensure that conductors are properly sized for a given application. Undersized conductors can lead to overheating, insulation damage, and even fires. Oversized conductors, while safer, can be more expensive. Therefore, it is important to select the correct conductor size to ensure both safety and cost-effectiveness. In addition to the NEC, other relevant codes and standards may apply depending on the specific application. For example, the National Fire Protection Association NFPA 70E provides guidelines for electrical safety in the workplace. It is important to be familiar with these codes and standards and to follow them carefully when working with electrical equipment. In the case of the 250 horsepower air compressor, it is essential to replace the existing 500 MCM conductors with conductors that are large enough to handle the motor's full load current. Based on the calculations, either 750 MCM copper with THHN insulation or 1000 MCM copper with other insulating materials would be suitable. When installing the new conductors, it is important to follow all applicable codes and standards. This includes properly terminating the conductors at the motor and at the disconnecting means. It also includes properly supporting the conductors to prevent them from sagging or rubbing against other objects. In addition to conductor sizing, it is also important to select the appropriate overcurrent protection device for the motor. The overcurrent protection device is designed to protect the motor from damage in the event of a fault or overload. The size of the overcurrent protection device should be based on the motor's full load current. The NEC provides guidelines for selecting the appropriate overcurrent protection device. It is important to consult the NEC and other relevant codes and standards to ensure that the motor is properly protected. In summary, properly sizing conductors for motors is essential for safety and reliability. It is important to consider the motor's full load current, the ambient temperature, the type of insulation used on the conductors, and the distance the conductors will run. It is also important to select the appropriate overcurrent protection device. By following these guidelines, you can ensure that the motor is properly protected and that the electrical system is safe and reliable. The NEC provides specific tables for conductor ampacity based on the conductor material, insulation type, and ambient temperature. Always consult these tables to ensure that the selected conductor is rated for the intended application. Remember to account for any directing factors that may apply, such as ambient temperature correction or adjustment factors for multiple conductors in a raceway. Furthermore, when dealing with large motors, it's prudent to perform a voltage drop calculation to ensure that the voltage at the motor terminals remains within acceptable limits under full load conditions. Excessive voltage drop can lead to reduced motor performance and potential damage. Voltage drop can be calculated using formulas provided in the NEC or through specialized software tools. If the calculated voltage drop exceeds the recommended limits, it may be necessary to increase the conductor size or take other measures to mitigate the voltage drop. In addition to the conductor size, the type of conductor material also plays a role in the overall performance and safety of the electrical system. Copper conductors are generally preferred due to their higher conductivity and lower resistance compared to aluminum conductors of the same size. However, aluminum conductors are lighter and less expensive, making them a viable option in certain applications. When using aluminum conductors, it's important to select the appropriate connectors and terminations that are specifically designed for use with aluminum. Aluminum conductors can form an oxide layer on their surface, which can increase resistance and lead to overheating. Proper connectors and terminations help to prevent this oxidation and ensure a reliable electrical connection. The choice of insulation type is also crucial for conductor performance and safety. DHHN insulation is a commonly used thermoplastic high heat resistant nylon coated insulation that is suitable for dry and damp locations. Other insulation types, such as XHHW, are available for wet locations or for applications that require high temperature ratings. The insulation type should be selected based on the environmental conditions and the operating temperature of the conductors. In addition to the conductors themselves, the raceway or cable tray system that houses the conductors also needs to be properly sized and installed. The raceway or cable tray provides physical protection for the conductors and helps to prevent damage from environmental factors. The size of the raceway or cable tray should be sufficient to accommodate the conductors without overcrowding, which can lead to overheating. The raceway or cable tray should also be properly grounded to provide a path for fault current in the event of a short circuit. Grounding is a critical safety measure that helps to protect personnel and equipment from electrical shock. The grounding system should be designed and installed in accordance with the NEC and other applicable standards. The grounding conductor should be sized appropriately to handle the available fault current. The grounding electrode system should be properly installed and maintained to ensure a reliable ground connection. Regular inspections and testing of the grounding system are recommended to verify its effectiveness. Another important consideration when sizing conductors for motors is the motor starting current. Motors draw a significantly higher current during startup than they do during normal operation. This starting current can be several times the motor's full load current. The conductors and overcurrent protection device must be able to withstand a starting current without tripping or causing damage. The NEC provides specific rules for sizing conductors and overcurrent protection devices for motor starting applications. These rules take into account the motor's starting current and the type of starting method used. The motor starting method can affect the starting current and the duration of the starting period. Common motor starting methods include across-the-line starting, reduced voltage starting, and variable frequency drives. Each starting method has its own advantages and disadvantages in terms of starting current, torque, and cost. The choice of starting method should be based on the specific application and the requirements of the motor. Variable frequency drives offer the most advanced motor control capabilities. They can be used to smoothly start and stop motors, adjust the motor speed, and optimize energy efficiency. Variable frequency drives can also reduce the motor starting current and eliminate the need for oversized conductors and overcurrent protection devices. They can provide significant energy savings and improve the overall performance of the motor system. However, variable frequency drives can be more expensive than other starting methods. The cost-benefit should be carefully evaluated before selecting a variable frequency drive. The overall design of the electrical system for a motor application should be carefully considered to ensure safety, reliability, and energy efficiency. This includes proper conductor sizing, overcurrent protection, grounding, and motor starting methods. Consulting with a qualified electrical engineer is recommended to ensure that the electrical system meets all applicable codes and standards and is optimized for the specific application. Proper installation and maintenance of the electrical system are also essential for long-term performance and safety. Regular inspections, testing, and maintenance should be performed to identify and correct any potential problems before they lead to failures or hazards. Qualified electricians should be employed to perform all electrical work. They have the training, experience, and tools necessary to safely and effectively install and maintain electrical systems. In addition to the technical aspects of conductor sizing and electrical system design, it's also important to consider the environmental impact of the electrical system. Energy efficiency measures should be implemented to reduce energy consumption and minimize carbon emissions. Renewable energy sources, such as solar panels, can be used to power the motor and reduce reliance on fossil fuels. Sustainable materials and practices should be used in the construction and maintenance of the electrical system. By taking these steps, we can create electrical systems that are both efficient and environmentally friendly. In conclusion, selecting the right conductor size for a 250 horsepower air compressor involves careful consideration of the motor's full load current, the ambient temperature, the insulation type, the distance the conductors will run, and the motor's starting method. Consulting with a qualified electrical engineer and following all applicable codes and standards are essential for ensuring safety, reliability, and energy efficiency. Remember to replace the existing 500 mcm conductors with either 750 mcm copper conductors with THHN insulation or 1000 mcm copper conductors using other insulating materials to ensure the air compressor operates safely and efficiently. The information provided is for educational purposes only and should not be considered a substitute for professional electrical engineering advice. Always consult with a qualified electrical engineer before making any changes to an electrical system. Electrical work can be dangerous and should only be performed by qualified personnel. Ensure that all electrical work is performed in accordance with all applicable codes and standards. This is just a guide. Local codes, laws, and requirements must be adhered to.